All right, let's begin. So, days and nights. How are days and nights caused? We are doing what? Space physics, unit 6.1. So, these are caused by the Earth spinning on its axis and making one complete revolution. Look, and the revolution causes 360, the whole revolving around the sun causes all these seasons. Simple, this part?
Yeah.
Okay, let's quickly move
Yeah.
on to our next point. This is what they are just telling us all the way over here, this thing. Let's now quickly talk about this side. No, this side. The Earth's rotation on its axis causes the sun to have an apparent daily journey from east to west. Whenever we see the sun, from where does it rise and where does it set? It always rises from the east and it sets where?
West.
In the west. So remember this as well. The sun, oh, the sun rises from the east and sets in the west and does this daily. Okay, every day. This is what happens. This is how we see the sun rising and setting. Now, let's talk about this part. Each day the sun is highest above the horizon at noon and directly due north on its northern hemisphere. This height itself is the greatest and the daylight are longest about 21 June. After that the sun's height slowly decreases near 21st December. It is lowest and the number of daylight hours is smallest. This is why we get summers in May, June, July, and we get winters in what? In December. Do you guys get this? Because the sun is
Yeah.
Yeah.
highest, it is like right above. That's why this is the cycle that we get. Do you get it?
Yeah.
Okay, I'll make
Yeah.
the frames along the lecture. This is what you'll need to remember. This is Earth and solar system. We are basically doing nuclear physics. No, sorry, space physics. All right. So this is an important part that you'll need to remember. See this rotation, the revolution of the sun, of the Earth around the sun. How is it causing all the seasons? Now, as you can see that the Earth is tilted, right? The axis of the Earth is tilted. It's revolving like this in this direction. Okay, it's not like this. Do you guys get this part?
Yeah.
So you need to remember this as well. Now let's talk about these tilts. The two factors responsible for these is the first is the motion of the Earth around the Sun once in approximately 365 days, and the second reason is the tilt of the Earth, which causes the seasons. So let's write it down. Let's make notes for this. Seasons. How are they caused? The first is the motion of the Earth around the Sun. Okay, so because of the motion of Earth around Sun, this causes the seasons. And what's the second reason for it? The tilt of the Earth. You all must know at what angle it is tilted basically. That is
23.5.
23.5 degrees. And how much time does it take for the Earth to complete one rotation? That is
365 days.
365
1/4.
days. Okay? Approximately 365 days. No need to go into too much accuracy for this. Is this part clear?
Yeah.
Okay.
Yeah, got it.
Now let's talk about the seasons that we have. What are the seasons that we have? We got 4 seasons,
Yeah.
right? What are those? Winter, spring, summer, and then
Fall.
autumn, right? These are the 4 main seasons. We must know the time period. When do they occur? It's very important. So when does winter usually start in the northern hemisphere? This is the northern hemisphere, the upper part of the earth, okay? This above side. Southern hemisphere is this part. Northern hemisphere is this part. Got it?
Yeah. Basically, North and South Pole, right?
Yeah. So we are talking about the northern hemisphere in this case. When does winter start in northern hemisphere? It starts
21st December.
yes. So it starts from December usually. When does the spring start? It starts from 20th March. What about summer? 21st June. And autumn begins from 23rd September.
Yeah.
Yeah.
What's the gap between the months for each of them? Can you see
Sorry, can you repeat that?
the interval? What's the interval of the months for each of
Two
the
to three
seasons?
months.
Yeah, 2 to 3 months, right? This is starting from December to March, December, January, February, March. Then 3 months, March to June, March, April, May, June, 3 months. Then June to September, June, July, August, September.
September.
Got it?
Yeah.
Okay.
We have like 9 months of summer here.
Yes.
It depends from
It
country to
depends.
country.
Yeah, that depends in which part of the earth you are, like at which hemisphere we are. That's why. Now, see this part, BCD. Over part BCD, this is BCD of the Earth's orbit, the northern hemisphere is tilted towards the sun so that the hours of daylight are greater than those of the darkness. That is, it is spring and summer. So during summer and spring, the days are greater than the nights. This is what they're trying to tell us here. Do you get it?
Yeah.
Yeah.
Okay, so let's make notes for this part as well. That during summer, CD, during spring and summer, I'll write it, yeah, during spring and summer, what is it? Days are, 1 minute, I'll write it here. Days are greater than nights. Easy. Any questions about the northern hemisphere, guys?
No.
Mm,
Okay, let's talk about the southern hemisphere now. As you can notice yourself, see, the northern hemisphere is tilted towards the sun in this part over here. The northern hemisphere is more close to the sun than the southern hemisphere, right? So, what do we say? See this part, what they're telling us here. I should not working 1 minute. Okay, see now. The southern hemisphere is tilted away from the sun and has shorter days than night, so it is autumn and winter there. What does this mean? What are they trying to tell us here? It means that if we have spring and summer in the northern hemisphere, it means that in the southern hemisphere, what will we have? We will have the winter and autumn. Got it?
Yeah.
Any confusion till here? I'll set this up
No, got it.
properly like this. This one down. Yeah, this is better. No questions related to this.
No.
Okay,
no.
so I'll still write it down in points. See, if northern hemisphere has winter and autumn, then the southern hemisphere will have what? Spring and summer. Okay,
Okay.
and why is that? Because if the northern hemisphere has winter and autumn, what would that mean? It would mean it is tilted away from the earth. Sorry, tilted away from the sun. And the below one is the vice versa of it. If the northern hemisphere is tilted away from the sun, it would mean that the southern hemisphere is tilted closer to the sun. Got it? So the one which is closer to the sun while tilt, that would have summer and spring.
Yeah.
Okay.
Yeah.
All right. That's pretty much about this. Now let's talk about the motion of the moon. Okay. So what do we know about the motion of the moon? Let's talk about this first and the phases as well. Uh, Make points here only. Okay, so how does the moon move and what is the moon basically? If I say define moon, what will you say? What would be the definition of moon? No idea?
I would say like it's like, yeah, I'm not sure.
Not sure. Look, Earth has one moon. Do you know how many moons do other planets have?
Multiple, well, one, two, well, zero to multiple,
Which planet
basically.
has the most number of moons?
Probably Saturn
Jupiter.
or
Jupiter,
Jupiter.
yeah. Jupiter
Hmm.
has the most number of moons. So all these moons are basically satellites. Okay? So you'll have to remember this. So if I say, like, if I write the definition of moon, moons, stars, sun, these are all natural satellites. Okay? So whenever you want to define moon, you will use the word that it is a natural satellite of the Earth. Okay? Do you know how big is our moon? Any idea about how large it is?
No, I'm not sure.
Not sure. Okay, I'll put down
No.
some important points for this as well. So one important point is, see this. It's kind of the, I guess, fourth or fifth largest moon in our solar system, our Earth's moon basically. What they are telling us is that it is what? It is approximately circular orbit. It is an approximately circular orbit, approximately once a month, at an average distance away of about 400,000 kilometers. And it revolves on its own axis in a month and also always has the same side facing the Earth so that we never see the dark side of the moon. What do they mean by this? Hmm. Any idea?
Mm,
Think of it. Think of it. No matter if you're wrong, we are just discussing it while making the notes. So that you'll also learn how to make points when you're reading yourself. See what are they saying? The moon is a satellite of Earth and travels round it in an approximately circular orbit, right? So
yeah.
how does the moon orbit around the sun? Take out the point from here. It orbits around the Earth. Okay, then approximately once a month. So how much time does it take to make the moon orbit around the Earth? See, they have written it over there. Let me know, guys. Do you see this line?
Once a month.
Once a
Yeah.
month. How much time does the moon take to rotate around the Earth? Approximately
Once a
once
month.
a month. If like I write it in more detail, I would say around 27 or 28 days it takes for the moon to revolve around the Earth. Got it?
Okay. Yeah.
So remember this, that it takes around, or approximately, it takes approximately 1 month for the moon to complete one revolution around the. Do you get it now? Any questions still here? We see the moon by reflected sunlight. So, does the moon provide its own sunlight, or do we get it through the color that we see on the moon? Do we get it because of the sun? Is the moon a provider of light? Like, does it produce its own light? It reflects the light from the sun, right? So,
Yeah.
let's write those points as well. Those are also important. Okay. So, how do we start? I'll change the color. Let's talk about the moon's light. What do we know about it? So the first thing is that it does not produce its own light. Does not its own light. So how do we get the light from the moon? It reflects sunlight. Okay, I'll continue from here. It reflects sunlight. Is this part clear?
Yeah.
Now, how do we know that the moon is revolving around the earth? We get to know about it because by the phases of the moon. Have you seen the moon? We get full moon, then we see it changing its shape like
Yeah.
this and this, right? These are the phases of the moon which tell us that it is revolving around the earth. Okay? So let's first talk about new moon, basically. Do you know what is a new moon?
Yeah, isn't it the one that's
Yeah.
like really thin?
It's like basically when the moon is positioned between the earth and the sun. That is when we get the new moon.
Yeah, it's like totally. I mean, it is like not reflecting any light from the sun, right?
Yeah. Okay.
Yeah.
That is
Okay.
when we get the new moon. Remember this as well.
Yeah, it's totally dark.
Okay. I'll share a picture of the phases of the moon so it is more easier for us to understand that part. Okay.
There's one in the textbook.
There is.
Yeah,
Oh yeah, here it is. See, yeah, here it is. See this?
the phases is the second
Yeah.
circle.
Now see this. This is what I was talking about with you guys. I was talking about the new moon. You see this? This is the earth. This is
Yeah.
the moon. And from here, these red rays that you see, this is the sun's rays. So when the moon is right between the earth and the sun, we get what? We get a new moon. Okay? So let's write it down. New moon. When do we get it? When the moon is between the sun. This is when we get the new moon. And what's basically happening here?
What is happening there?
When we have a new moon.
Yeah, so it's totally dark. We
Yes,
can't.
exactly. The side that is facing the earth would be what? Dark. Okay? Is it what's happening here as well? See, the blue color is showing the part where we have darkness. The yellow part is the one where we have light,
Oh, okay.
right?
Okay.
So see here, this is all yellow. That means we have sunlight over here. And this is all darkness. All of it is what? Dark that is facing the earth. So if it is dark, we are not able to see this. Or are we able to
Yeah,
see this?
not with the naked eye.
Not with the naked eye. And the earth also receives the sunlight, correct?
Yeah.
So we are able to see the sun and the sun rays, but the moon vanishes. We like doesn't really vanishes. Like we are not able to see it because it is a new moon. The side that is facing the earth is in total darkness. That's why we are not able to see the moon. Understood?
Yeah.
Or Mariam Samin, you guys get it?
Yeah. Yeah.
Okay. Then as the moon revolves and reaches this part, then it looks like this. This is the shape that we get when it is rotating and it is at this part. When it is right at the first quarter, we see half moon like this. When the moon is away, basically, on the opposite side of the sun and the earth, that is when we get the full moon and we are able to witness it completely. When we are seeing the full moon, whenever you come across the moon and you can see the full moon, what does it mean? It means that the earth is here, the sun is here, and the moon is over here. Got it?
Yeah.
Yeah.
This is when we see the full moon. And in a new moon, what's the case in the new moon? In the new moon, the earth is here, the sun is here, and the moon is in between the sun and the earth. So it becomes completely dark from here. This part of the moon is completely dark. So let's write down the phases in more detail now. So I think it's a better picture. Is it visible to you all?
Yeah.
So that you all can
Yeah.
like relate what does the moon look like. So from now onwards, you have a good knowledge. Like when you see the moon, you know that where it is on the earth from the sun, right? If you see
Also, what
like
about
yeah.
what was the time period of the
For the moon to
moon?
complete this one whole rotation,
Yeah, it
around
was 28 days,
27
right?
days, yeah, 28 days. Approximately 1 month. You always write approximately 1 month for the moon to complete one revolution around the Earth.
Yeah, okay.
Okay? So they could ask you when do we get a full moon? Whenever the moon is or at this side of the sun and the earth. When do we get a new moon? This phase. Okay?
Okay.
Waxing quarter, waning quarters are the first quarter and the last quarter. This is the first quarter, this is the last quarter. I'll write it here as well. This is your first quarter. This is your last quarter. Okay?
Okay.
All right. This is one thing that you all need to remember. This numerical that you see over here. The average speed is equal to the total distance upon total time. So, if you are asked to find the average orbital speed of anything, what will you will be using the formula that is v is equal to 2 pi r upon t. Why? Because what is 2 pi r? 2 pi r is the distance that the moon needs to travel to orbit or to complete one whole revolution. Do you get my point?
Yeah.
Yeah.
Right? We need the distance. So the distance would become the circumference of the moon or the earth. If you're talking about the earth, then the earth would be revolving around the sun. And if I want to ask that what is the orbital speed of the earth, so what will you do? You will find the circumference of the sun because that is the distance the earth needs to travel, right? And you divide it by the time period, how much time it takes for the earth to complete one whole revolution. You will get the orbital speed of the earth. In the same way, if this is the earth and let's say now the moon is rotating around it, so now what? You find the circumference of the earth through 2 pi r and you divide it by t. T is the time that the moon takes to complete one revolution, that is around 1 month. Do you guys get this?
Yeah.
So do not forget this formula. V equals to 2 pi r upon t. 2 pi r is the circumference of the orbit. Any questions, Elia?
Also,
Yeah.
is there a mnemonic for the phases of the moon?
Mnemonic for the phases of the moon. We can make these mnemonics ourselves. I'll make a mnemonic for the phases of the moon and I'll share it with you. Or
Okay.